Hello and good morning, everybody. This is Bogdan Cudzilo from TriStar. Um, Today we're going to be going through BOM management and PTC Windchill. This is going to be the first part covering what I call the basics of doing BOM management in Windchill. This webinar will be followed by another where we'll cover more topics around this area. So I'm going to use a combination of slides this morning and getting into the Windchill system. I'm going to be using Windchill 11. There's a few enhancements in Windchill 11 for those who are using Windchill today around the BOM management area, just in terms of usability and ease of use. So that's what I'll be using today. So I'll just give people maybe another couple of minutes to join this webinar, and we'll start shortly. Also, this webinar will be recorded. It will be posted to our website for replay purposes for those who cannot stay for the whole time, or if you want to share this with your colleagues. And in your question and answer or your chat window in the GoToMeeting session, you can enter your questions if you have them. I'll try to get to the questions towards the end of the webinar. If I don't get to your question, we'll try to follow up if you provided your email with some of the answers. And as always, if you have more interest in this or you want to see a more detailed presentation or discussion around how Windchill works around BOM management, or how TriStar can help you transition to BOM management in Windchill, by all means, you can contact your TriStar sales representative, and we'll be happy to take a look at how we can help you. Okay, so let's get going. We have a lot of things to cover in this first session. The topics I want to go through today in this seminar, or this webinar rather, are just the basics. What is BOM management in Windchill? You may have heard WTParts, parts. What are these? Why do I need them? How to create or manage bills of material in Windchill. You may be doing it today just from your CAD side. How else can we do it? So I'll go through some examples in that area. I'll also go through, well, why do we do this in Windchill? Why would we want to do some BOM management? Some companies will do this in their other systems, maybe in their ERP, MRP, MES systems, or just through Excel files. So what value does managing a BOM in Windchill bring to a company? And then we'll take a look at and go in depth in, well, how does this actually look like in Windchill, and how can we manage the different types of BOMs that that exist within the company. They may exist in different locations. Different stakeholders may be owners of them, maybe editing them, but at some point that type of bill of material exists. And then we're going to go through some questions and answers if you have any. Okay, so the basics, what is that WT part? So traditionally, the way that the BOMs are managed in a lot of companies is through a drawing, right? So the drawing is pretty much the manufacturer's key, right? If the drawing is lost, it has to be recreated, or else we don't have information to input into ERP, or manufacturing doesn't have any reference to what the part is. So someone needs that drawing. So a lot of companies are very drawing centric because that's the way that has been efficient in the past. So in the drawing you have a lot of things. Some companies have more or less of this, but you typically have a BOM table where you have part numbers, find numbers, quantities, You may have the rev of the parts. You may also have things like process notes that are attached to certain line items on the part or on the BOM. And all that information is actually on the drawing itself. So if something needs to change, someone needs to update this drawing. Right? So if one of these process notes changes from manufacturing, the engineering drawing needs to be updated. And then people have to wait for it to be updated downstream. So really the drawing is kind of the key, and people have to wait for it to be complete, to be changed, to be revised, to be updated. So that potentially can introduce a lot of delays into your product development process. If I have a change on a note, I may not need to have the drawing update. The note could exist somewhere else. Or if I have a change in the BOM item that is not design related at all, maybe it's a consumable, I really don't need to change the engineering drawing because that doesn't affect the design in any way, the form, fit, function of the part or the assembly. So we can't get away from drawings, but we can kind of split out some of the functions of a drawing. So then changing becomes more efficient. What does that mean? So in Windchill, Windchill can manage an electronic BOM that may come from the drawing. And the way to do this is by introducing a Windchill part record. So a Windchill part record is kind of similar to like an ERP item master or ERP record. It's a special object in Windchill that is just referencing things. So it's a collector of content. Typically, these parts will be represented by a part number. Right? So the part number will be the identifier of that part. There may be different part numbers used within the company. There may be part numbers that are internal numbers. There may be part numbers that are from manufacturers. They may have a different part number. So purchasing will use that number to order the part, and somehow this needs to be linked to that internal part number. So sometimes companies will have an attribute that has their own internal part number and then a manufacturer's part number for ordering purposes. On the electronic side, if you have multiple manufacturers or vendors that you can order the part from, depending on geography, depending on your supplier agreements, how can we represent one part number with multiple different vendor numbers? Just doing it with attributes becomes cumbersome. So this part was developed in Windchill. It's just a container of information, and it's the mechanism to enable functionality with Windchill, such as BOM management, such as ERP integration, supplier management, document management, and so on. So it's really the foundation of enabling enterprise change, right? Because why would we use this? Well, if there's a change to a part number, what does that change impact? Well, typically it impacts the physical design part, the CAD file. It impacts potentially documents that may be some specs or requirements or reference documents, downstream user manuals. Maybe it may impact the sourcing of a different supplier. Maybe it may impact inventory. If that part's not available in inventory, can I use another one instead? Can I use a different alternate or a substitute part that has similar fit and function, form, fit, and function? Or can I just use a different one from a different vendor at that point? So it's really the container that points to different things, and if there's a change, I can respond to that change really quickly if I have all of this information in one place, such as Windchill. typically this information is not in one place in companies, and they have to kind of find out all this information from different stakeholders. So that kind of delays the response to that change potentially. So in Windchill, this Windchill part can make up a structure. It can also be represented by different content that describes the part, right? So you could have a CAD file that describes that part number. You could have some information from attributes, maybe documents, and so on. So Windchill itself has, out of the box, different types of parts. So there's a mechanical part, there's an electrical part, there may be some supplier parts. So really the Windchill part is kind of like the OEM, the item master in Windchill. And different things can be linked to it, as well as other parts that describe it. So typically there may be some supplier part numbers that describe the part. And I may be changing those supplier part numbers, but maintaining a single OEM part internally. I don't need to create a different part number internally unless it's a different fit function. I may just want to change some supplier parts in that case. Those supplier parts or those other types of parts like electrical or supplier parts can also have things associated to them, like the metadata, which are just attributes, typically attributes associated to that part that describe its description, cost, finish, other attributes, color. There may be data sheets, maybe compliance information, if it's a regulated part. And there may be these parts used in different product structures, represented by different supplier parts, potentially. So the hierarchy typically in Windchill is a Windchill part. There are classifications of parts. There are various modules in Windchill that introduce other parts. One example is a electrical part from the ECAD Workgroup Managers, software part. Now you don't need to have these modules specifically, but they are typically used in that regard, as well as supplier parts. So typically parts will be described by some content. Right? So the content could be a CAD model. So I may have one or more CAD files describing that part. And typically the part number of the CAD model will be the same as the part number of that item master part in Windchill. Although I can have multiple CAD models describing one part. If I have reusable parts, I don't need to create separate part numbers for my different CAD system. I could just have one of these Windchill parts and the same part numbers from different CAD systems. There are various link types between these parts, so something has to be the master or the owner. The other ones are just going to be the contributing content. And Windchill can then create these derivative files from the CAD, such as PDF of a drawing, DXF step files, IGES files. Those will be coming from the CAD, but they will be also representing that Windchill part. So if you have people within the company not being able to access the CAD model directly, they can still access those derivative files if someone needs to get a PDF of a drawing or a step file of a part. These Windchill parts can also be created as families. So I can branch out a Windchill part either as an instance of that family owner. So in the case of managing colors, they will typically have their unique part numbers, their unique instances. But from a physical part function, they may only be represented by one CAD file, a generic XXX part file. And the color will be dependent on which product or variant of that design that part is used in. So how do we create BOMs in Windchill? Typically there's 4 ways of doing this. One way is to, as the CAD assembly is being checked into Windchill, is to auto-associate. That means a corresponding Windchill part will be created. And these are in these gray gear icons. Those icons can be changed depending on part type, depending on the part. Customers have these different colors. Customers have, maybe electrical parts, green, regular parts, gray, maybe other colors. Another way to create a part is to manually create a part in Windchill. So for example, if I'm creating things like consumables like Loctite or some shipping packaging or artwork or straps or glue, oil, what have you, I can create these in Windchill. They will not exist on the CAD side. They don't have to. They may be only used for manufacturing, but then I can create and add these to my BOM structures directly. I can also create parts in Windchill by importing a spreadsheet of a parts list. So either a parts list or a BOM with various levels. So all I need is an Excel file with column names that match the Windchill attributes, typically the number, the name, or the description of the part, the revision of the part, the life cycle state, and other things that you may put in, other attributes. So those then can be imported into Windchill, and Windchill parts created off of those. If those parts already exist as CAD models, you can associate the existing CAD model to these parts after the fact. Another way to import parts into Windchill is just from ERP or from other systems through some integrations, like an ERP integration. So I can, populate my existing Windchill system with parts that already exist in my ERP system or my other BOM management system. That way, my CAD is associated to my parts, so I know what I'm using in the released parts in ERP. And when there's a change, I just need to flag it in one place, and then when I'm pushing back those changes with the ERP integration, I can push those changed parts back to the ERP system. Right? I don't need to have someone enter that information back into the ERP system manually. So what are the benefits of doing BOM management in Windchill? One of the common items today is duplicate BOMs. Right? Designers create the BOM, they create the drawing, they create the parts. That BOM then either gets sent over as a PDF or Excel file, and then other stakeholders will keep a copy of that for their purposes. Purchasing might need information on that latest design so they can start ordering parts ahead of time, those longer lead items. Suppliers may need information around BOMs so they can respond to providing content to the customer. That typically may happen through emails or PDFs or Excel files again. Some companies have supplier portals where they can get that information directly and securely from within the company. And then, of course, a lot of it happens also through manual entry. There's typically a BOM configuration management person that just enters that information from a drawing or from an Excel file. So a lot of those are just different copies of that BOM. They're disconnected. When there's a change, all of these stakeholders have to, kind of update their BOMs, assess the impact of changes to their BOMs, And how do we do this? Typically through an Excel file or some other system. They have to compare BOMs from design to what exists already on the production side or in the ERP side. So there's time taken in performing those updates. The sharing of those BOMs is typically or may not be secure if you're sending them by email. Traceability is lost. You know, how do I trace back who has what version? IT may maintain multiple systems, a lot of space on network drives, maintaining access to those network shares. And then if you're doing a lot of manual entry, you just some people just make mistakes, typing errors, miss something. So the accuracy of the BOM may not be that great. So what would the benefits of a part-centric approach be? So for the designer, if I'm managing a BOM, I'm kind of not relying on the drawing that much for changes, for communicating information. For the designer, they can focus more on designing. They can reduce the effort of creating BOMs, exporting out BOMs, maintaining BOMs for other departments. They can kind of work more design in context and make better decisions on what their product needs to do versus what files they need to generate for other people. For the enterprise, you can find and access and reuse information really quickly. If that information is in Windchill, you can access it through the web browser, through PTC Navigate, through other apps, and get to that information. That could lead to faster responses to change, quicker time to release, for IT, fewer systems. Let's take a look at some of the BOM management functionality in Windchill in terms of the BOM types. So typically, the different BOMs will exist within the company. For example, on the planning side, this is typically the PLM system or product development system like Windchill, where through the planning phase, I'll typically have a rough engineering BOM and then a more complete engineering BOM. I may then maintain a manufacturing BOM, and as that is pushed for execution into maybe downstream ERP systems, another BOM will be maintained, right? The manufacturing BOM or the as ordered or as maintained BOM. What am I manufacturing to? And then as the product is sold and the customer is coming back for service, there may be a service BOM. So kits, service items, that replacement parts that may be managed as another BOM. And this is, it could be in different systems. It's kind of on the border of a PLM ERP system. But each of these systems are interdependent. If there's a change, that change needs to propagate between these two systems, either getting back to engineering, or if engineering makes changes, getting back to the execution. So typically there are different BOM types. Some companies have more or less of these. They may take different shapes as they're getting transitioned. For example, it will typically start from an as designed state, kind of move into the as manufactured or as as planned before it gets manufactured, and then you'll have the as built BOM. How do we actually build it? And then what did the customer ordered, and my service BOM. How am I maintaining this BOM? So in Windchill, these various BOMs are designated as view streams. So there'll be a BOM view. Now the BOM view may contain parts that are in different views. And there's a downstream context and an upstream context. So if there's a change and it propagates downstream, it just means it goes from engineering down to manufacturing and down to service. There may be propagation the other way. Service may change something, manufacturing may change something, and that information needs to get back to engineering or the design BOM. So Windchill has these concepts of upstream and downstream. The engineering BOM or any of these BOMs can also kind of split out for different manufacturing locations. So I might have a BOM for something that I'm manufacturing in plant 1, which is in one location, but I may also have something that I'm manufacturing in plant 2 in a different location. There may be different parts that I'm sourcing. It may be different manufacturing, work cells that I'm using, different equipment, different consumables for that site. Maybe different part numbers. So sometimes that may be split out and kind of managed that way, not only sequentially. But all of this is just driven by one part number, right? So that part that I have in engineering will typically be the part number that I'm using in manufacturing. So all of these different BOM views are connected by a common part number. So typically, a BOM will get created from a CAD structure, the typical process. That CAD structure will create the corresponding Windchill part structure, or the EBOM, or the design BOM. These could be termed whatever the customer feels makes sense in their environment. Some customers don't like EBOM because that could represent electrical BOM. But this is the engineering BOM. Items can get added to that engineering BOM. So other components, other parts, other assemblies, maybe from electrical, maybe from consumable side. That structure can then be pushed to the manufacturing MBOM or reworked, reordered to create other structures, other gathering operations for that specific manufacturing process. They could also be created, parts can also be created on the manufacturing side to contain things like kits. And then through the release process or workflows within Windchill, that final planned structure can then be released to downstream execution systems like ERP for actual part ordering and manufacturing purposes. So if there's a change, that change can easily propagate between these different BOMs, and the different stakeholders are aware of what's impacted. So in Windchill, one example of a BOM view is when I create an assembly and I have a component structure, that component structure will be in a certain view. So in this case, I have the engineering BOM view. The user can then transform that view for manufacturing purposes. So I might have the same top level assembly part number, but in this case used for manufacturing. And those manufacturing parts within that assembly may just consist of different operations or grouped parts for that specific operation, or just a structure that represents very closely the design structure, but just for for manufacturing purposes. There may be a few differences. I can then transform that to a service structure. And so I may have service items in there, or service parts directly. So they're all linked by one part number. So if there's a change to one of these, the other item will get flagged in Windchill. So the user will then have to make a decision of, does this change impact my BOM in any way? There may be different stakeholders that are owners of these different BOMs. Engineering may be the owner of the engineering BOM view. The manufacturing engineer may be the owner of the manufacturing BOM. And then the service department may be the owner of the service BOM. So each stakeholder will identify, is this change going to affect my BOM? And if it is, I can understand the impact of that change in Windchill. Windchill, that OEM part, that internal Windchill part number, can also represent different manufacturer parts. They may have their own part numbers. Through the Windchill supplier module, I can manage the approved manufacturer, approved vendor lists that are linked to my own internal part number. These are usually for purchased parts or buy parts. But in this case, I can specify which part number I'm sourcing for this internal part number. So I may be buying this from a vendor, and I might have different vendors for that single manufacturer part. Windchill can also allow me to designate whether those manufacturer vendor parts are the approved or the preferred, or parts that I should not use anymore. They're obsolete. They may have been used in previous versions of that OEM part number, different revs, but now they've been discontinued and I'm using a different vendor, different manufacturer part. But I still need to keep that history. So if the product that I sold a couple of years ago was using the old manufacturer number, I know exactly which one to replace it with. All that information can be linked together in Windchill. Companies may be doing this in other systems today, but in order for an efficient change management process, if I bring this into Windchill, I can respond to that change fairly quickly. So as an example, how does this look like in Windchill? So in Windchill, I can attach these vendor or manufacturer part numbers to my OEM number. Once those are attached, I can then understand the relationship of those parts, which manufacturers, which vendors I'm using, who are the preferred, who are the approved vendors for that part. So this gives visibility into engineering such that if they want to replace a part, they can easily understand that maybe for one of these parts I don't have, if it's a buy part, I don't have a supplier part for that. So I may just make a decision to use a different part, or communicate with purchasing that we need, we need to purchase this part. So as an example here, my two position toggle switch has, in this case, different manufacturer parts and vendor parts. You don't have to use both of these. You could just use a vendor part, but it has a different part number that I'm tracking from Mouser. Another example is maybe manufacturing internally, but maybe a single sheet metal part needs to be represented by some manufacturing data. So in Windchill, I can have my internal part number linked to a Creo model, maybe the flat state, a drawing of that part, maybe a SOP document. But then for manufacturing, I might also want to attach some manufacturing information. And these are some Creo manufacturing files. Those would be then directly attached to that internal part number, and in Windchill I can quickly go and see, you know, if there's a change to this part. Do I need to update the, you know, the drill file? Do I need to update the drawing? Do I need to update the model in any way? Does my SOP change if I have a process change? And how does that get propagated within the company? So here I have a manufacturing version of that part which links to different content than the design version of that part. And in this case I also have a flat phantom manufacturing part. This manufacturing part just groups content for manufacturing that may be pushed to my ERP system, but it doesn't really exist as a, you know, as a part in ERP. I can't order this part. It's a phantom in-process part. So Windchill allows me to designate these Windchill parts as, you know, kind of temporary placeholders, not actual physical components. Another example could be things like packaging and artwork. You know, how do I associate packaging to my my BOMs? Well, I can define, for example, a packaging part. This may have a different icon. It may be described by you know, things like packaging documents, or some artwork files that may be coming from other applications, Adobe, CorelDRAW, what have you. So those could then also be linked to my bill of material as a reusable item or a design item directly within Windchill. So typically I can pass information once that BOM, that planned version of the BOM in Windchill is created, between my ERP systems, and then also synchronize information on that part. Sometimes I may want to get things like inventory and cost from my ERP systems for planning purposes on the PLM side. So I can extract attributes from those systems and represent those on the Windchill parts. So on the Windchill parts, on the design side, I may not care about inventory and cost, but for planning purposes and BOM management, I may need that information. So instead of logging into ERP systems manually, checking that information, I can synchronize the two and work efficiently. So I'm going to get into the system. I know we're kind of running here on time. I do want to show you some of these items within Windchill. So here, what I'll do is I'll get into the Windchill system and take a look at how do these BOMs look like. So here in the Windchill system, I have my my Windchill CAD model that's coming from Creo. I also have a Windchill part that represents that CAD model. In my case, the part number of the CAD and the Windchill part is different. In most cases, they would be the same, because if I'm searching for a part number in Windchill, I want to get the same part number for both. So they could have the same part number. In my case, they don't. You don't need them to have the same part numbers, but that depends on your design process. So here, if I look at this Windchill part, this Windchill part also has a little diamond, blue diamond, kind of at the lower bottom left corner of that icon. That represents something called an end item. This is the top level item that is a sellable item. So there may be modules or kits within that product that I can sell as a sellable item. It cannot be broken out into separate components. So I can designate some of these parts in Windchill as those end items. That differentiates just component parts versus what the top level part is. So it has a designation called an end item. Now, for these Windchill parts, I can also designate whether these are make or buy parts. So what is the source? So they may have different access rules. They may have different uses within the BOM in terms of change management. So here's the top level part. If I go into the related objects of this Windchill part, in the related objects, this is the linking to other content. So this part is just a content container. It's represented by this CAD assembly. That's why it has this little viewable icon to it. It's just inherited from the CAD model. If I, for example, go in and look at another part, here I have a part that I created just for Loctite. It's a specific part number internally that I'm using, but this is used for manufacturing purposes only. Right? So this is a by source part. I just uploaded this little image as a placeholder, so you can put any images you like, any 3D models you like to these parts. But this one here is a consumable item that's managed within Windchill. This may be in my library as a standard item. So, going back into my car here, if I go into my part structure within Windchill, this is where I'm going to see the bill of material, represented by that assembly. Now, most of these parts within this structure are coming from CAD. Right? So this part structure is built directly from my CAD model, my CAD assembly, as I'm checking this in. I'm going to switch different browsers here. So if I look at my structure here, this shows me my components within my my structure. Some of these are like the transmission, the chassis of this car. They are end items themselves because they could be used in other models. So they are sellable items themselves. Now, some of these parts could also be reused, but these are top level items as well. If I click on this top level assembly in Windchill, I can also get this visualization on the side of this component. So when I'm looking at the BOM, I have the 3D the 3D view beside it. I can also expand out this structure. So here I'm going to look for a board part that's going to represent the PCB board. Now this one here has a different icon because that's coming from the electrical side. If I take a look at components within that assembly, that sub-assembly, I can see that a lot of these are electrical components. Now in the sourcing status column, I do have some of the supplier information, so there may be some approved suppliers for these components. So if I, for example, select some of those components, I can show what are those approved manufacturers, approved vendor part numbers. So these are their part numbers, and I can see who the manufacturer is that I'm using. So now this is a different part that's just linked to that one part number. That PCB assembly may also be described by some documents. It also may be described by some CAD files. In this case, there's a schematic, there's a mechanical assembly that is describing that item within the BOM. So if I'm doing some change management, I can, for example, flag that this needs to be changed, and I know exactly what this is going to impact. It's going to impact the ECAD department, the mechanical department, and they will then need to examine, changing these two components if I need to make changes to them. So all that information is in one place within the structure. So here what I'll do is I'll just show whatever's related to the top level. So there is a Creo assembly. I can also kind of expand out the rest of these parts and show related information to everything within the structure. So it's kind of at my fingertips. Now here I see that there's some parts related to this structure from the mechanical side. There's a drawing that's related to this front wheel assembly. There may be other things that are related, such as documents, to all these items within the structure. And Windchill gives me the ability to run a report. So I can do for example, a report that just summarizes, just show me a multi-level BOM report, maybe with some manufacturing information, maybe just show me the manufacturer parts. I can also create reports that show me all this information in one place, as well as any change information I may need. Okay, so I want to just finish off this presentation just giving a really simple view of BOMs within Windchill. Next time we'll get into some additional topics on the next webinar. I also want to highlight just some of our time limited offers on TriStar's website. If you haven't seen these, there's a link directly here to it. This is going to end the webinar for today. I want to respect the time. I'll take a few questions if there are any at this point. Okay, so there were some questions about about Windchill views. So the Windchill views are created either manually or through other modules within Windchill. So one typical module within Windchill, which we'll cover on the next webinar, is NPM link. That allows me to create and associate manufacturing views, and any changes to the upstream or downstream view will get propagated to or will get flagged in the other view, so the user will understand what is that change. For them to change the BOM itself, that needs to be their decision. Windchill will not change your BOMs for you, but it will alert BOM discrepancies. Okay, another question is, what are the differences between vendor parts and manufacturer parts? That just allows me to, kind of track, what is the part number that is being manufactured, and who am I buying it from, right? So sometimes you may use one or the other or both. If you're just buying part numbers from a vendor, you don't need a manufacturer part. The vendor may have different part numbers for that component depending on where they're sourcing it from, so that way you may also track the manufacturer part number. So it depends on the situation where you're getting that information from. Another question was, is it possible to update the EBOM and the changes propagate automatically to the MBOM? So typically you don't want to do that. You want to have visibility, but I just, the MBOMs are the ones that are used in manufacturing. I don't want, without some kind of validation or approval, I don't want changes on the design affecting my manufacturing parts. Because then ERP users will see a new part number or new rev of that part number pop up, and they'll be wondering, is this a new part I have to manufacture too? So remember, Windchill is only a planning system. It's not an execution system. So yes, I can see the visibility of the change to the EBOM, but is that something I want to commit to what's in my ERP system? Typically, the MBOM in Windchill will kind of match what your MBOM in ERP is. And those two have to be synchronized. Otherwise, there's no point in doing an MBOM in Windchill. So Windchill will flag that there's changes to the MBOM or to the EBOM. So if I'm looking at an MBOM, I can see that some parts within my EBOM have changed. What do I want to do now? Do I want to update my MBOM or not? If I want to revise my MBOM, update it, and that's going to change, then once I approve that, then my MBOM will update automatically from the changes to the EBOM. But there's got to be a user to make that decision. If the user is the same as the user maintaining the EBOM, then yes, you can you can easily update the MBOM, and the changes will get propagated from the EBOM directly. I'll just take one more question. We're kind of running up on time here. What is the best way of getting started in the BOM in Windchill, transitioning from a drawing BOM? So, doing BOM management in Windchill, there's got to be an end goal in mind, right? If you want to kind of not rely on the drawings that much and put more information into Windchill, the first place to start is understanding, well, what am I going to be removing off of the drawing? Is it the BOM itself? Is it just some some consumables that I'm managing in Windchill instead of on the drawing BOM? How am I going to communicate that BOM? How am I going to synchronize it with the drawing BOM? So typically the process is, we can help customers to determine what are the best practices in the transition from one to the other, and what do we enable in Windchill to do that. There's also PTC University courses on BOM management. They'll kind of go through the basics of how this works in Windchill, how the drawing information is propagated into a Windchill BOM. How do I link the BOM balloons to the defined numbers on the BOM in Windchill? That could be all automated when you're checking in the CAD model. So there are some courses on PTC University you could find useful to go through that information. Okay, I want to thank everyone for their time, and part 2 of this webinar is, I believe, in 2-3 weeks. We'll cover more of these topics around the BOM side, especially the EBOM to MBOM transformations and different types of variant and configurations of a BOM. So I want to thank you for your time, and have a great day.